Most of us here have the sense that AI has the potential to change the world for the better and to push all of humanity forward. To realize this potential, AI needs to be able to run at the embedded edge, wherever it is needed, and it needs to be able to do this independently. And to meet society's needs, AI needs to be explainable, it needs to be fast, and it needs to be economically and energy efficient. Good afternoon. I'm Govind Wathan, and we are Literal Labs. And we are on a mission to create a new AI architecture that is fast, ultra low power, and explainable for the edge. Implementing AI at the edge can bring significant value to a multitude of applications, be it medical or industrial. McKinsey puts this at upwards of 500 billion US dollars of additional annual economic value. Today, AI for the edge is typically solved using neural networks, but this does not solve all issues. Our customers are telling us that the high amounts of investment that is needed in order to implement AI at the edge is slowing down adoption. And this has a lot to do with the compute complexity of neural networks. The cost of new and expensive hardware, the reliance on network availability, and the need for AI experts to train and deploy model are some of the factors that is limiting the adoption of AI at the edge. And we want to change that. Through years of collaborative research between the University of Newcastle in the UK and the Center of AI Research in Norway, a new technique to machine learning emerged. One that uses a combination of data binarization, propositional logic, and settling machines. The resulting logic-based AI algorithms drastically reduces the compute complexity. And this leads to higher throughput, ultra low power, and more explainable AI for the edge. And the best part of all, these solutions can be retrofitted into existing silicon chips. And over the last decade, we've moved from promising theory to realizable potential. And here are some of our recent results. We first start with XGBoost. XGBoost is a popular AI algorithm. It uses decision trees in order to run regression as well as classification tasks. It is a good choice for a number of applications such as fraud detection as well as risk assessment. When we ran our models against XGBoost, our models outperformed XGBoost by being 250 times faster at the same level of accuracy. Next up, we have a fully connected autoencoder, and this is a neural network. It's good at feature extraction as well as anomaly detection. And when we ran our models against the FC autoencoder on the same hardware, same conditions, we were 54 times faster while being 52 times lower power. Now, this changes the game and makes AI a lot more accessible for the embedded edge. Now, those were mind-boggling numbers, but where our models are becoming really impressive is when we look at real-world scenarios. So if you look at the numbers here, these are measured results of our logic-based models when applied to a water flow prediction system for a water utility company in the UK. Notice the tiny memory footprint that our models occupy on device. And our ultra low power means that we're able to run one prediction every 5.8 seconds for the next 10 years on a coin cell battery. Or one prediction every second for the next 10 years on a AA battery. And so this is really making AI a lot more accessible for these highly constrained edge-embedded devices. Now, I've talked about the tech, and you've seen some of our numbers. Let's dive into the product itself. At the center of our product offering is a training tool. The training tool takes in customer data sets through a customizable API, and we then Booleanize the data and iteratively analyze and refine the data. And what we end up with is a number of models. These are all logic-based models. And what the tool then does is it selects the best fit model based on the customer's criteria. And this model is then deployed at the customer's preferred silicon. And since our models are tiny, they are able to run on existing silicon. And also, they're able to run on the CPU directly without the need of GPUs or accelerators. Our training tools are provided through a subscription model, and we license out our models on a royalty fee. We estimate our SAM to be at $18 billion, and that is considering the embedded edge AI market, looking at markets such as drones and medical devices. Today, we have got customer engagements with a water utility company in the UK, a large automotive tier 1 company in Europe, as well as a large food supply chain company. And each of these are doing something different with the model, and we're seeing very strong traction. The team is comprised of highly experienced members. At the helm is Noel Hurley, the former GM and VP of the CPU group at ARM. And we also have a highly experienced group of founders and advisors. We recently closed our pre-seed, where we raised £4.6 million. And this takes us through getting the product out into the market, scaling the team, and completing our product market fit activities. With that, I thank you for your time, and I welcome any questions.
Hey, let me start with the first one. Very cool to see the inference speed really going up and doing that at the edge. My only question here is it primarily, you showed XGBoost there?
Yeah.
Does it primarily just work with this kind of decision trees? Or you're also looking at some of the other AI models that you could compress and do faster?
Thank you. So XGBoost, the reason we chose XGBoost is because it's a highly optimized model. And when you look at edge AI and solutions in edge AI, the primary AI models that are used today are neural networks. And that's about roughly 80% of embedded edge solutions. Decision trees are another. And decision trees are smaller. They're more efficient. And that's what XGBoost is. And that's the primary reason we chose it, is because we wanted to go after something that is highly optimized, fast, efficient, and has a good ability to handle large data sets. And that's why we chose that. But we also pit ourselves up against a neural network, as shown on the next graph.
Hey, so thank you. So I heard you mention a few customers that you already have. In the deck, I noticed that you're also talking a lot about technical problems that you're solving. But for a customer to pay you for this, there's a business problem that you're solving. So can you talk a little bit through what business problems that you're solving?
Sure thing. So when you look at the embedded edge, a lot of companies understand that they can gain a huge competitive advantage if they were to adopt AI. The problem that they face is the high capex. It's a lot to do with capital investment and less to do with operating costs. If you think about capital investment, by the year 2030, it is estimated that we will spend $6.7 trillion on new hardware and new infrastructure just to enable AI to work at the edge. And this is the problem that we're solving by enabling customers to utilize our models that are fast, efficient, and explainable in existing hardware without the need of mainline power and without the need for additional network infrastructure.